Yes, sir.
Welcome to the Computer Science Igcse, and today we are continuing Chapter 7. It is our paper 2, and the Chapter 7's topic is linear search. Okay, so first, a search is used to check if a value is stored in a list, performed by systematically working through the items in the list. Okay, so linear search means that we need to search something in a list. What do you mean by this? Let me tell you. Look, there is a list, right? There is a list. I'm making a list for you. Okay, in this list, we have some data. Like, let's suppose we have some numbers like 9, like 6, like 3, 11, 2, 7, 12, 5. These are some numbers. Okay. And these are the index, like 1, 2, 3. These are the positions, right, Nana? 5, 6, 7, 8. How many positions we have?
8, sir.
And how many elements we have? Of course, 8. Okay. Now, I wanted to search 2 in this list. This is called list. What it called?
A list.
Okay, in this list, I am going to find out a number. And the number is number 2.
2.
Right? Okay. Now, we are going to do a search that is called linear search. So there are standard search methods, but you need to understand one method for our computer course. And that method is called linear, which inspects each item in a list in turn to see. Oh my God. Okay, what number we have to find? 2. So I need to start from the position 1. What is the first position 1 number? 9. So I have to go through this. Can you tell me the next number? 6. Then
3.
Then
11.
And then we find our number. So we have to move in a sequence, turn by turn. Is that okay or not okay?
Yes, sir.
Okay, perfect. Now, listen. For example, searching a name in a class, list of students' name. So what we are searching? We are searching a name. What we are searching? Searching a name of students, where all the names are for different. So in our example, we need to take some names, right? So I'm going to rub it and I'm going to write down some names here, okay? Okay. So let me write down some names for you. Okay. So the names are John, Martin, Ali, Jack, Robert, Massey, Ronaldo. Do you know these guys?
Yes, sir.
Okay. Do you like them? Will Smith.
Yes, sir.
Do you know Will Smith?
Yes, sir.
Who is he?
An actor.
Yes. Yes, I love him. I love him. Okay, now back to the topic. So, how many names you see in a class? Let's suppose this is a class list. So, how many students are there in a class?
8.
Okay, now let's start writing the algorithm. First, output, please enter name. Then you need to input the name. So what name you are looking for? Massey. Let's suppose we are looking for Massey. So we input Messi, MESSY. What is the name you entered?
Messi.
You wanted to find out. Now found is false because we are about to start the searching. So right now it is false. Then counter one. We are starting from the one. Look here. What is the name on position one?
John.
Okay. Now computer is going to use a loop here. Why computer is using a loop?
So I can repeat searching.
Yes, because there are number of students in the class, so the program need to search every name. So he must use an iteration. Okay. So if name equals to student's name counter, what does it mean? See, if name, what is the name in there?
John.
No, dear.
Oh, sorry, Messi.
Okay. So is if Messi name is an student name. Student name means this is a table and this table name is student name. I'm just writing STN. STN means student name. Okay. So if it is a student name on a counter, how many counters are there? 8. So computer is going to start from 1 and the first name is John. So is it our search equal or not equal?
Not equal.
Not equal. Now move on. Move on to the next page. Let's suppose if it is equal, then found will be true because we got my name on position number 6. So the found will be true right here. Else, counter is equal to counter plus 1. If we did not find our name, so the counter will work from 1 to 2, 2 to 3, 3 to 4, 4 to 5, till 8 times. And if. So our loop will work until found, like we found Messi. So our loop will complete. Or counter is greater than class size. Can you tell me what is the class size? 8. So the
8.
counter will move on 8 and stop because there were no names. So let me erase it just a second. I'm making it clear. Oh. Okay. Fine. So if found, then what you have to do? Then output name, Messi. Found on position. Can you tell me Messi position?
It was number 6.
Yeah, so number 6 will be print here with the name Messi. Then else, if the name is not found, then you need to print name, not found, and if. So this is how the algorithm works for the linear search. It is going to search one by one, one by one. Is that okay?
Yes, sir.
Did you understand it?
Yes, sir.
Perfect. So I'm going to write down names again for you because mistakenly I have deleted, and you start writing this array in your notebook because it is not in your book. So you have to write it down. Linear search algorithm. Once you're done with this, first you need to write down this chart. First you need to write down this chart, what I have drawn. First you need to write down this chart. Okay, John, Mac, Robert, Massey. Why Massey is moving down? Okay. Massey, Donald, and we are going to take, oh, no, no, no. Okay, right here I'm taking Aliza and Nana. And what else name I take? Rio. Okay. So these are some names you need to first make this list, write down the index, position numbers, everything. And then you need to write down this algorithm. Quick. You have only 5 minutes. Once you're done with this page, let me know. I will drag you to the next page. Look, this is the next page we need because it is half here and half here. Okay. Are you there?
Yeah.
Okay. Are you working?
Yes.
Okay. There's a new topic that is called bubble sort. What it called?
Bubble sort.
Bubble sort. What is bubble sort? It is also a part of searching data. Like if you're going to search anything, you can use bubble sort as well, right? Are you getting it or not?
Yes, sir.
Now let's start the topic. Just a second. Let me clear all the things so I will make it again. Okay. So list can be more useful if the items are sorted into meaningful order. Now we are going to sort the data. What does mean by sorting? Sorting means to write down the numbers in ascending order or descending order, isn't it? Or you can write the names from alphabetical order like A, B, C till Z. Or you are going to write the alphabetical order in this way, Z till A, right? So this thing is called sorting. This thing is called sorting. For example, names could be sorted in alphabetical order. The same thing I teach you here, look. Or temperatures could be sorted in ascending or descending order. Look, let's suppose I'm taking temperature 21, 32, 23, 34, right? These are the temperatures. So we need to write all the temperatures in a ascending order. So the 21 will be on top as usual, 23, then 32, and then 34. So this is how the sorting works. Did you get an idea or not?
Sir.
Did you understand it or not?
Yes, sir.
Okay, now, so
That's what I thought.
this method of sorting is called bubble sort. So you are going to search something and then you need to sort something in an alphabetical form or in an ascending or descending form. These all things are come under bubble sort. Now, each element is compared with the next element and swapped if the elements are in the wrong order. What do you mean by this? Let me tell you detail. Okay, I'm going to make again a list right here. Okay, so in this list, I'm going to write down some data. First, let me draw the lines for you. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I'm going to write down the temperatures. Temperature 37, 35, 33, 31, then 28, then 34. That's it. These are some temperatures, okay? Now, what I want them to write in ascending order. What do you mean by ascending order? From smaller to bigger, right?
Yes, sir.
Okay, now what happened? We need to compare the values, both values. Oh, let me write down the numbers like 1, 2, 3, 4, 5, 6. How many temperatures we have?
6.
6 temperatures. Okay. Now I wanted to write down my data in ascending order. So the first is 37 and the second is 35. So is it a swap possible here?
Yes, sir.
Yes. So we need a variable. A variable. That variable name is temp. T E M P. Temp means temporary. So we need a variable temp. So now what we have to do, listen, starting from the very first element and finishing with the next to last element. So we start from first and we need to search till fifth because the last comparison is between fifth and sixth. So the computer will stop on this point because in the last computer have to compare these two values, not these two values, because there is nothing right here. So the computer is not going to check this thing. Okay. Are you getting
Yes,
it?
sir.
Okay, great. Okay. Now what we have to do, listen. Once it reaches to the end of the list, we can be sure that the last element is now in the correct place. Now, once we're done with the comparison of every number, all the numbers should be in ascending order, right? So let's start swapping. Okay, can you tell me 37 and 35? So we need to put 37 in a temp value, temporary value. Look. So 37 moves into temp. So this will become blank. Now, which number have to move up? 35. So once 35 is here, then the space of 35 is gone. Look. Now what we have to do? We need to store temp value right here in this position. 37. Now the temp become empty because 37 is gone. So look, the numbers are swapped.
Yes, sir.
Now, can you tell me the next swap? Hello?
Yes, sir.
What is a swap? Right here. Next swap. The next swap is between 33 and 37.
Yes, sir.
Which value is bigger?
37.
37. So we need to put 37 in the temp. And now the temp stores it and this become empty. Now what we have to do? We need to swap 33 right here. And again, 37 will move right here. And temp become empty because values is gone. Now, what is the next procedure? Tell me.
31.
Perfect. So in this way, the swap continues and all the numbers are being arranged. Now, however, other item in the list may be out of order. Look, these two numbers are still out of order. Did you observe it?
Yes, sir.
So each element in the list is compared again from the last one because we know the final element is in the correct place. So once we've done all the swapping numbers, then again we need to swap. Then again we need to swap until all the numbers should be arranged. Is that okay or not okay?
It's okay.
Perfect. Okay. Now let's move to this part. Now we have another algorithm. So in this algorithm, we have temperatures. What we have here? Temperature.
Temperatures.
Okay. So now let's start it. First is equal to 1 and last is equal to 10. What does it mean? They are talking about the positions like 7, 8, 9, and 10.
10.
So how many temperatures we have?
10.
10 temperatures. Okay. Repeat. Why we are using loop here? Because the number of times is counted every time. So 1, then 2, then 3. So that is the reason we need to use a loop because the values are going to be iterate one after another. Swap is false because once the program is started, the swap is false. Now we are starting the program for index first to last minus 1. These values are called index 1, 2, 3, 4, 5, 6, 7, and 9. These values are called index. The
Index.
positions are called index. So these are the positions. So they are taken first, number 1, to last minus 1. Can you tell me last minus 1 mean?
Last.
Last minus 1. What is the last value? See?
10.
So minus 1, it becomes 9. I told you that 9 and 10 will be compared with each other. So we take 9
Yes.
as a last value. Did you get this concept? Because
Yes, sir.
whom we are going to compare 10, there is no more element. So 10 is not the last value. The last value is 9 here, right? So we are going to take 1 to 9 for.
Yes,
Okay.
sir.
If temperature of index. So what is the temperature of index right now? Let's suppose it is 35 and it is on position number 1, index 1, is greater than temperature index plus 1. What is the value of index? 1. Index plus 1 means 1 plus 1, 2. And the temperature is 33. Look here, 33 is here on number 2. So what happened? See, then the temperature index will be stored in temp. Look, so 35 will be stored here in a temp variable. Then what happened? Temperature of index is assigned to the index plus 1. Now, this 33 is going to be moved up. It's going to be moved up. Look here.
Up.
Then what happened? Temperature of index plus 1 will equal to the temp. What is the value of temp? 35. 35 will be stored index plus 1. What is the value of index plus 1? 1 plus 1? 2. So look, they are now in a order, 33 and 35. So swap true. And if next index, it means that now the comparison is between 2 and 3. But Nana, 2 and 3 is already in order. So are they going to swap?
Yes, sir.
Perfect. So last is equal to last minus 1. So the 10th value, once it reaches to 10th value, so the 10th value becomes 9. Why 9? Because the comparison is done between these two. So until how much this loop will work? Until the loop is not become swap or result is equal to 1. Sorry, last is equal to 1. So the swap will not possible. So our loop will be terminated. Is that okay?
Yes, sir.
Okay, now write down the heading of bubble sort. First, you need to make this whole diagram. And then let me know. So I will drag you to the algorithm here. Okay. First, draw this in your notebook. Validation and verification. Okay. So validation is the automatic checking by a program that the data is reasonable before it is accepted into a computer system. When data is validated by a computer system, if the data is rejected, a message should be output. Okay, what is validation? Like, do you know about the driving license?
Yes, sir.
Yes. So here is a date on a driving license that the driving license is valid for 1 year. Let's suppose someone makes his driving license in February 21. So the driving license will be valid for 10 years, let's suppose 33. So that till 2033, the driving license will be valid. What happened if the person is driving the car after 21 to 33? What happened?
It's invalid.
It's invalid. So the cop, so the police will stop the person and accuse the